Good morning, everybody. This morning, we're going to be talking about ammonia. We're going to be talking about ammonia. And what we're talking about ammonia, the symbol for ammonia is NH3, NH3 gas. It's an alkaline gas that turns moist, red litmus paper to blue. It is very important, gas, and it is also important chemical reagents in the lab. We use it to convert so many cations in the laboratory as well. Then it is at hydride of nitrogen. It is a hydride of nitrogen because hydrogen is attached to nitrogen. The hydride is coming from from hydrogen, and the oxidation number of hydrogen in this regard is is minus, while that of nitrogen is +3. Okay, good. Then how can we prepare this in the laboratory? Aside this, it has what we call a choking or irritating smell, just like your normal urine. Therefore, it smells like your normal urine, meaning your urine contains ammonia. And aside this, in the laboratory preparation of ammonia, how can we prepare this ammonia in the laboratory? Therefore, to prepare this particular ammonia in the laboratory, we need what we call ammonium salts. Ammonium salts we're talking about. Ammonium salts here is, you can get a salt from chloride. Therefore, if you are getting a salt from chloride, this NH4 plus, this chloride ion, then combine, you have NH4 plus Cl. This is what we call ammonium salts. From ammonium chloride, then you can have calcium hydroxide. Then the calcium hydroxide here is a non-volatile base. Calcium hydroxide CaOH2. And there's something you need to know about this particular base. Why do we call it base? Because it contains OH minus. Yeah, because it contains OH minus. Why? Is because one, it is very cheap. Two, it's not direct present. What do we mean by not direct present? Direct present are those that will form a solution, add to the solution. This will not add to the solution already prepared. Unlike when you have sodium hydroxide and when you have potassium hydroxide. When you have sodium hydroxide and you expose it to the atmosphere, you will discover that the sodium hydroxide will form what we call solution, sodium hydroxide aqueous. Therefore, the two reactants must be properly grounded. Why must be properly grounded? In order to increase the surface area so that the reaction can work fast. Therefore, but they are both solid. Since they are both solid, what we need to do is to ground it in order to increase the surface area of this particular reactant. When you do that, it will increase the rate at which the reaction occurs, and probably when it occurs, it's going to form this. And how does it form this? It's very simple. You have calcium 2 plus, you have OH minus, then you have NH4 plus, then you have Cl minus. Therefore, we always believe that unlike charges attract while like charges repel. Therefore, the plus will go and meet the minus. When the plus meet the minus, they exchange their valency from the oscillation number to valency. Therefore, they exchange the valency to form, you have 2 here already, you have Cl minus. Therefore, there will be an exchange of ion here to give you what we call calcium 1, then give you Cl2. Basically, then when this and this react together, you will have expected to form NH4, then OH minus. But because this is very unstable compound, it will decompose to form NH3 gas, NH3 gas plus H2O. Therefore, basically, this was going to form. Therefore, automatically, when you break it down, this was we are going to have calcium chloride, water, and ammonia gas. Now, how can we dry this particular gas in the lab? Probably we use what we call a quick lime. A quick lime is what? It's only the drying agent that is suitable for what? Drying ammonia. Silica gel may equally be used, but why we're using calcium? Why we're using calcium oxide, or call it calcium oxide, right? Why we're using calcium oxide is because it will not add to the solution, just dry it up. And when you look at this particular laboratory, the drawing of the laboratory preparation of ammonia, you discover that this is where we put our measure our what make sure what the non-volatile base, which we call calcium hydroxide, and the ammonium chloride. Then we eat gently, while we eating gently, so that we can break it down. When we break it down, then the ionized ions can combine together to make a reaction to occur. And when it happens, what happens? This is the condensed water vapor here to cool the gas, and then what happens here? The gas entry here. Then when the gas enter here, it gets to what we call a drying tower. Now the drying tower, what is there is to put a calcium oxide, because we need a dry ammonia gas. We need a dry ammonia gas. Therefore, we have to supply the calcium oxide. And the essence of supplying the calcium oxide is just as the gas is coming from the round bottom flask, it gets to this particular place and enter what we call this, get in contact with the dry water, and the dry water will dry the gas by removing the water vapor that could have been inside with the gas. Okay, good. Then we collect it by this what we call upward delivery wire, because it's pointing upward delivery. And the reason why we're using the upward delivery is because ammonia is less denser than air, is lighter than air. The air compared to density of ammonia to that of air, discover that is very, very, because ammonia here is NH3, nitrogen is what? Nitrogen is 40 plus 3 will give you 7, so it's about 30 when you compare with that of air, that is about 15. Discover that it is less denser than air. Therefore, this can be collected by what? Upward delivery. And aside this, you need to understand that yes, moist litmus paper is being put here. Why? In order for us to be sure if the gas that is produced is ammonia or not. Therefore, if you turn red litmus paper to blue, the moment it turns the moist red litmus paper to blue, then we can say the gas that is inside is what? Ammonia. That's basically this is how to prepare ammonia in the lab. Then we equally talk about the industrial preparation of ammonia. How can we prepare ammonia industrially? For us to prepare ammonia industrially, there is we use what we call ABA process. ABA, even add about ABA process. Okay, the process named after the man that invented this particular method. And what he did was to mix what? Nitrogen gas and what? Hydrogen gas in the ratio 1 to 3, which is very, very important. In the ratio 1 to 3, in order to get you ammonia gas. And for this to occur, the reaction must be a reversible reaction. Means equilibrium must reach where the rate of forward reaction must equal to the rate of backward reaction. And aside that, we need what we call a catalyst, and defined ion is what we use as a catalyst. A finely divided ion. A finely divided ion is what we use as a catalyst, and the temperature must be 450. The temperature here must be 450 degrees Celsius. And aside this, The pressure, you have to apply pressure about 200 atmospheric pressure automatically is needed, and the catalyst to speed up the reaction. And what happened in this particular process, about 15% of ammonia is being produced, and this ammonia that is being produced is a gas. You can easily liquefy it. It's being liquefied and cool. When you liquefy it, you cool it, while the oil gas is what recirculated for further production, because it is a reversible reaction. It can go back, reprocess, come back, and it can continue to do that. Therefore, the ammonia molecules have what we call pyramidal shape. How for pyramidal shape, you need to understand what we mean by pyramidal shape, because when you look at ammonia, now we say NH3. Okay, good. And the nitrogen there is 7, which is the central atom. I hope you know. Then when you do the electronic configuration, you discover that you have what we call 1s2, 2s2. They have 2p. What's remaining is what 3. What's remaining is 3. Therefore, in the hybridization, one of 2s2 we mix with what? Here you have this one, we have 3 degenerating orbitals. I hope you know. Therefore, you have one of what? 2px1 plus you have 2py1, then you have what we call 2p01. By the time they hybridize together, they form what we call sp3. Therefore, in this case, we are going to have sp3 just like this, just like this, just like this, and just like this. However, the 2, it has one lone pair of electron that is coming from what? X. Then the unpaired electron is coming from what? From the remaining P. Therefore, it can combine with the neighboring hydrogen. You can have hydrogen here. Okay, you can have another hydrogen here to fill up the gap, because you need to understand that the unpaired electrons, these are unpaired electrons, they are the one that involve in the what combination and the what chemical bonding, while the paired electron, this pair electron, it doesn't involve in what chemical bonding. It's from what we call reduce the shape along the axis to about, I'm not too sure about this, but I think to about either 105 or 105 thereabouts. This hydrogen, and this. Yeah, because of this particular lone pair of electron, we call this what we call pyramidal shape. It's having what we call a pyramidal shape. And the presence of lone pair of electrons that I've shown you here, and the difference electronegativity value of nitrogen and hydrogen makes ammonia molecule what? Polar. Yes, you can see the difference you can form when they say polar. You can have told you before, you can have something like this plus, then you can have something like this or minus. You'll be wondering why am I having minus and plus, and you need to understand why we're having minus and plus, because there is an hydride of nitrogen. Therefore, because of these hydrogen bonds occur readily between the ammonia molecules, automatically between the ammonia molecules and between ammonia and water. Therefore, you can, what we're saying now is we can have, and the excess of this particular hydrogen between these. Therefore, you can have this what we call hydrogen bonding. And when we're talking about hydrogen bonding, we're talking a dipole-dipole attraction. It must be between two molecules at least, between hydrogen and a very strong electronegative element. Here we're picking what? Nitrogen. And it can equally have it between ammonia or water molecules. And the excess of this hydrogen bonding, one, it will jump up the temperature of that particular compound, as I like, create tension on the surface, therefore not allowing that particular thing to get boiled easily. Therefore, this is the reactor, this is the reactants going to the reactor, Then you mix them together in the ratio 1 to 3, enter the the reactor as a catalyst that will call what finally what divided ion. And what happens to the finally divided ion? They mix together in this particular reactant. Temperature must be 200. The pressure must be 200 atmosphere. The pressure must be 200 atm. And outside this, the temperature must be 450 degrees Celsius. Then when it happens, it goes towards fractionation column. When the ammonia gas is being what cool and condensed and get it out from the what reactant. And the process continue. You see the process continue. The uncombined ammonia will go back to the reactant and the whole process will continue. Then we equally talk about the Fontaine experiment. Why we talk about the Fontaine experiment? It's a very simple thing because you know that ammonia and hydrogen they're extremely soluble in water. Therefore, we can use the what a Fontaine experiment for them. And the essence of this Fontaine experiment is to determine their what extremely soluble effect of this particular gas. And when you look at this particular contain ammonia, you can use ammonia or hydrogen chloride gas, dissolve in the first drop of water, drop in the first drop of water, you dissolve it in the first drop of water that reach to the bottom. And what happens? That reach top of the water, the tube, what happen? The gas will go up to the water, to the top of the water, of the tube, so that the fountain of water rushes up to fill the vacuum. Here it filled the vacuum. Then you can test the gas in the vacuum. If you are using water ammonia, it will turn your litmus paper to blue, moist litmus paper to blue. But if you are using hydrogen chloride gas, it will turn from what blue to what red. Therefore, it all depends on what you are using to get this particular ammonia what done. And the very soluble gas will show this effect. And this very soluble gas we're talking about here is ammonia and hydrogen chloride gas. Then we talk about the properties. That's about a colorless gas, but this colorless gas with a choking smell or irritating smell. Just like your normal urine, it contains ammonia. You can use litmus paper to test what your urine is it an acid or a base? And you can do that to confirm for me. It is poisonous, when you inhale it in large quantity, it could be dangerous to the system because it affects what we call a respiratory muscles. Good. Then there is an alkaline gas. I've told you about that. It is less dense than the air. That we can use we can use the upward delivery. It is a very soluble gas, very, very soluble. That's why we can use it in a fountain experiment and give this to the readiness with which it form hydrogen bonds with water to give aqueous ammonia. I told you the hydrogen bond can occur between ammonia gas and water, and to form what we call aqueous ammonia, which is NH4 aqueous. And the aqueous ammonia is ionized slightly to give what we call ammonium ion and the ion. The hydroxide ion gives aqueous ammonia its weak alkaline properties. You know what we're talking about here is when you have NH3 gas and you dissolve it in water, because of the hydrogen bonding between them, it's easily form NH4 OH aqueous. And this ionize slightly because it's a weak base, slightly in water to give NH4 plus and OH minus. And the presence of this indicate the what? That the solution or the gas is an alkaline gas or a base. Okay, good. Then we talk about the chemical properties of ammonia. Ammonia bonds readily in oxygen. Especially in oxygen, anything that has hydrogen in the compound is likely to form water. Therefore, it bonds in oxygen to remove ammonia and get it towards hydrogen gas. And to get it towards nitrogen gas. Yes, it bonds readily in oxygen, but not in air. The difference between Oxygen, air is a mixture of oxygen, nitrogen, blah blah blah. But you need to have removed all the other gases and leave oxygen alone. And when you leave oxygen alone and they combine that oxygen with ammonia, tendency of forming what? Nitrogen gas. And the color is greenish what? Yellow flame to form water vapor and nitrogen gas. Therefore, the color here is what we call a greenish yellow flame. A greenish yellow flame will be what's giving off. Then the presence of what? Yes, platinum. Yes, it can catalyze. However, it can react with air. If you decide not to remove the other component, then you need a catalyst called what? Platinum. And it will not give nitrogen, neither it will give nitrogen through oxide. That is in the presence of what? If you have to use air, then you must introduce a catalyst. And this catalyst is platinum. Good. And if you not form nitrogen, you form nitrogen through oxide. Fine. Then as a what? You can have them as a reducing agent. When you talk about reducing agent, talking about a compound that undergo oxidation. And when you talk about oxidation, we're talking about addition of oxygen over what? Hydrogen. In this particular case, what will happen to the hydrogen? Hydrogen will be removed. Therefore, what has happened here is hydrogen as a reducing agent, while copper oxide as a what? Oxidizing agent. Therefore, the copper oxide will what happen? We oxidize the ammonia gas to what? Nitrogen, giving it water, so the hydrogen. Then this man called reducing agent will go and reduce copper oxide to what? Copper solid. Now, therefore, as a what? A reducing agent, you can pick copper oxide and what? Ammonia gas. Then it reduces chlorine as well. You need to understand it reduces chlorine to hydrogen chloride gas and what? Nitrogen. The hydrogen chloride gas reacts with excess ammonia to produce a dense white film of what? Ammonium chloride. Sometimes there is a conforming test for ammonia. Therefore, what they are saying here is it can react with chlorine. Ammonia can react with chlorine to form ACl, which is ammonium chloride gas, and what? Nitrogen gas. And what happens in excess, you need to understand, in excess what? In excess ammonia, then it can react with ACl to form what we call ammonium chloride solid, and this to produce what we call a dense white film of ammonium chloride. This reaction is very important, and when you look at it, it's a sublimation reaction. A reaction that is going from gas what? Solid. That is what is actually happening here. And when it is done in excess, it's react with chlorine to give ACl gas, ammonium chloride gas, and what? Nitrogen gas. But in excess ammonia, it's react with what? ACl, which is hydrogen chloride gas, to form ammonium chloride solid. Fine. Overall, then you can have it. When you now have excess ammonia with what? Chlorine, what happens? When you have ammonia with chlorine, it forms ACl and nitrogen gas. But then when you have excess ammonia gas and with chlorine, it forms ammonium chloride and nitrogen. What is common to both chlorine gas is nitrogen that is forming. Therefore, if it is in excess, for ammonium chloride. If it is not in excess, it's from ACl. The ammonium must be supplied in excess for this reaction to form ammonium chloride solid. If, however, chlorine is in excess, what happens? If chlorine is in excess, the nitrogen 2 chloride will be formed. Nitrogen 2 chloride will be formed, which is NCl3. An explosive and oily liquid will be formed. An explosive and oily liquid, which is nitrogen what? Nitrogen 2 chloride. Okay, nitrogen 2 chloride will be formed. An explosive and oily liquid will be formed, and that will happen when excess chlorine is supplied to what? Ammonia. Therefore, we talk about ammonia reacting with chlorine if it is not in excess for nitrogen gas and ACl. If ammonia is in excess, it will form ammonium chloride, solid and nitrogen gas. But if chlorine is in excess, it forms HCl gas and nitrogen 2 chloride, which is very explosive. Then talk about the reaction with carbon dioxide. Also about 150 degree, it's about 150 degrees Celsius, and the pressure is about 150 atmospheric pressure. Then what happens? Ammonia reacts with what? Carbon dioxide to produce urea and an important organic compound. It's very important organic compound. Is derived from uranium. Urea, which is NH2 into 2CO, which is called organic what compound. That when ammonia gas react with CO2 in the presence of very high heat, which is about 150 degrees Celsius and 150 atmospheric pressure, it forms what we call urea, which is an important organic what fertilizer, organic what compound. Okay, let's see if we want to against using. Then the thermal decomposition at the temperature above 500 degrees. What happened? Or doing prolonged sparking, ammonia decomposed to form nitrogen and hydrogen. Then as a base, fine, as a base, ammonia is a weak base because it can accept proton to form what we call ammonium ion. It reacts with acid to form ammonium salt. What are we talking about here? If you have ammonia, there's a lone pair of electron here, then you have H plus, that has nothing on the surface. Then what happens? These coordinate covalent bonds, it can donate this electron to this particular proton to form what we call N. This what we call hydrogen plus. Therefore, to form NH4 what plus ammonium what ion. This is what we call it ammonium ion. And why? Because ammonia gas is a weak base. Why? Because it accepts protons. It's accepting what proton due to the availability of lone pair electrons. And it can equally react with what? Acid to form what we call. Ammonia what? Salt. Yeah, but when it reacts with acid to form salt, it's very simple. This one will break down to react with this to form NH4 plus, then SO4 2 minus, then they combine together to form what we call this particular salt. Then, as a precipitating agent, aqueous ammonia precipitate the insoluble hydroxide of metals from their solution of their salts. And a very good example is lead. And you need to understand that when you have aluminum, you have zinc, they are both gelatinous. But lead is not gelatinous. To form a gelatinous precipitate. Therefore, when you have a lead 2 plus reacting with ammonia in drop, it's going to form white precipitate, which is called lead hydroxide. And when you have zinc as well, it's formed white gelatinous precipitate, zinc hydroxide. Then when you have iron 3, ready brown, these are the color for the cations. And when you have copper, it's formed blue precipitate. For copper, it depends on the salt you are adding copper to. It can form either gelatinous or just ordinary blue precipitate. And you now need to understand that some of these hydroxide, like copper hydroxide, zinc hydroxide, dissolve in excess ammonia to form a complex ion. Basically, this is what we use when we are confirming them in the lab. In that particular case, the complex ion formation is used as a confirmatory test for copper and zinc in quantitative analysis. Some of these hydroxides, like copper hydroxide, zinc hydroxide, dissolve in excess ammonia to form what we call a complex ions. And the complex ion formation is used as a confirmatory test for copper and zinc in quantitative analysis. And a good example is Now, when you have the precipitate reacting with excess ammonia, excess aqueous ammonia, what's forming is forming what we call this is a complex ion called deep blue solution. It means the blue precipitate will dissolve to give a deep blue solution of this complex ion at OH minus. And this zinc, the white gelatinous precipitate will happen when you add excess ammonia, get dissolved to give what we call a colorless solution. To give what we call a colorless solution, so which is what we call a complex ion. Then test for how we test for the ammonia in the lab. First, test for ammonia in the lab. As you can see here, we need a Bunsen burner. To get us heat, we need a test tube. We need to put a solution. We need a moist red litmus paper. Now, when you dig a close to the what? To the test tube, you put or we call it a damp red litmus paper into the what? Glass jar containing the unknown gas. Then you are going to have a shocking smell. Fine, because I've told you it smell, and you turn that moist red litmus paper to blue. And what is happening here is turning the red. It's turning the red to what? Blue litmus paper. It's turning the red to blue litmus paper. Therefore, this is what is going to happen. Actually, the Bunsen burner burns the solution. The solution is burned. It releases gas, and when it releases the gas has a choking smell. You don't need to move closer, and the moist red litmus paper turns to what? Blue, and that confirms that the solution is an alkaline gas, which is likely to be what? Ammonia gas. Then this to confirm truly if it is an ammonia gas. When you now pass it through concentrated hydrochloric acid, pass it through concentrated hydrochloric acid, what happened? See what happened. You pass it through concentrated acid. Well, you're going to see what we call a white films of what? Ammonium chloride will be formed, and what's happening here? These white films of what? A dense white film is as a result of ACl, or is as a result of ACl that is combining with the ammonia gas, giving you what we call NH4Cl solid. That's what is actually happening. And when you have this, what happens? A dense white film will be formed as well. Okay, good. Now let's talk about the uses as well. It is using something that is very important. Temporary hard water. I use this ammonia to soften what's temporary hard water. When talking about temporary hard water, the water that contains soluble calcium hydrogen, that is like calcium or magnesium ions of what? Calcium hydrogen of hydrogen carbonate. Therefore, it can form with the calcium hydrogen carbonate. So this so-called temporary hard water. Therefore, softening this particular temporary water, we can use ammonia. And aside that, in the laundry as well, we use it to remove grease and equally what? Oil stain. We use ammonia as a solvent to remove grease and oil stains. Then we can use it in the refrigerator as well as refrigerant, although it's less toxic compared. We talk about having irritating smell. Therefore, it's not good for us to use as a refrigerant. Rather, use nitrogen, which you can use as a cooling agent instead of using aqueous ammonia. It is used in the manufacture, which is important. Acid, talk about it. Not only amino acid and sodium carbonate. Then it is used in the manufacture of fertilizer, ammonium sulfate, ammonium nitrate, ammonium phosphate. Yes, there's NPK, then carbide as well, carbamide. These are the use of what? Ammonia.